So I want to illustrate the concept of a non-porism versus a quasi-porism with this sort of pseudo-Poncelet with two caustics. So I have this black circle centered at this black dot, and I have two internal circles, red and green. They have the same radius, and they're equidistant from the center and collinear. So their centers are equidistant from black, and they're collinear. Okay, so I have these two circles. And here's the first example. I'm going to do a Poncelet transverse using the red circle for the first two iterations and the green circle for the next two iterations. Now, as I move P1 across the black circle, I can see that I'm not closing this n equals 4 family, but there will be positions of P1 when I do close, for example, here. Okay? But I'm not stable. I'm not in a sort of stable porism here. Let's call it that way. Okay, so closure is not maintained. Now let's do a small variant on this, which I'm calling the alternating caustic, okay, configuration. So instead of doing red, red, green, green, I'm now doing red, green, red, green. So I've sort of alternated or interspersed the caustic usage. And I can, of course, tune the radii, the equal radii of these two red circles, okay, or the distance between their centers, like so, okay, and I can make this tuning in such a way that if I pick, for example, a good radius here, this one, let's go ahead and do this manually. So 25, 275, let's go on 280, 9, 3, 4. Yeah, I'm pretty close now, okay? So I've now manually adjusted the equal radii of these two circles in such a way that visually and numerically here the distance between the first vertex and the fifth is near 0. Now let's go ahead and rotate P1 about the black circle. Look at what happens. I nearly maintain the porism. Okay, so the number that I'm indicating up here is the square of the Euclidean distance between the first and the fifth vertex. And you can take as reference the fact that the radius of the black is 1. So I'm showing here that this distance is 0.1, 2, 3, 4. So it's something like 10 to the minus 5 squared. So the distance is actually, the actual distance will be the square root of that. So something like 10 to the minus 3, 1,000th of the circumradius. Of course, I can do a better adjustment, and I actually think I have one here that I did a really good adjustment, this one. So now we can see here that for this particular choice of tangencies, I have this sort of quasi-maintenance of the porism, not perfect. So there's obviously something going on here with this particular map that maintains closure, whereas this other map here, when I actually do red, red, green, green, I cannot maintain that. Whichever tuning that I do here, okay, whichever tuning that I try to do, if I play around with D, the distance between the centers, and I, for example, right here can find, yeah, this D is going to make it, it's going to make the two circles become close to being concentric. But let's say I accept that this quadrilateral is closing. As soon as I move my P1, I break closure. Okay, so this is not something that is going to lead me to a quasi-porism, whereas the other configuration where I alternate my caustics leads to a quasi-porism. So no idea. Why is it that one construction does it and the other one does not? Please let me know if you have any insights into this. Thank you.